Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in 200 days. So yes, today we are going to start the first chapter of Inorganic Chemistry in PU2, that is D and F block elements. Okay, so this is a very important topic for your KCET examination and it is a very scoring and theoretical chapter. Okay, you do not have many formulas here, just you need to know certain important reactions and certain important theories. Okay, so yes, we'll be covering this chapter holistically. We'll be covering the PYQs, we'll be covering a lot of practice questions. So yes, please watch this complete video so that you can master this particular topic. Okay, so now one more request is please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section. So if you join this WhatsApp channel, you can get the PDF of these notes, you can get the questions, you can get the solutions. So it will be really beneficial for you if you join our WhatsApp channel. Okay, you will not miss out on any important documents like notes, questions or solutions. Clear? Okay, so now I'll be telling you that today's topic, I'll be covering D and F block in two parts, like in three parts, part 1, part 2 and part 3. So today it is the part 1 of D and F block where we are covering the very basics of this particular chapter, that is position in the periodic table and electronic configuration. Okay, this is something very basic thing, not a very long topic, very short topic, but yes, the fundamentals, the basics we will going to cover. Okay, so yes, now let us go to the first lecture, that is I'll be telling you how are we going to cover this particular topic. So I told you there will be three parts, part 1, part 2 and part 3. So in part 1, okay, that is today's lecture, in part 1 I'll be covering the position in periodic table and electronic configuration. Okay, only this much in this today's topic. Next, part 2 is general properties of transition elements. So you might see that this is only one topic will be covered, but yes, in this general properties we have 14 properties to cover. Okay, 14 properties will be covered. So yes, very important. Now you need to understand each and every property. So this will be the most important lecture of this particular chapter. Now coming to part 3, I'll be having again, first is important compounds. So here we'll be discussing about potassium dichromate and potassium permanganate. Then we'll discuss about lanthanides, their configuration, some reactions, and lastly we'll be ending this chapter with topic number 6, that is the actinoids. Okay, I hope the distribution of the chapter is very clear. So we'll be doing 3 lectures on this. Today's lecture first part will be covering these 2, and in the next second lecture we'll be covering this one, and in the third one we'll covering these 3 important topics. Okay, so yes, now coming to the weightage. So weightage is also very important. It's a high weightage topic. I can say every year we can expect 2 to 4 questions from this particular chapter. Okay, so you can see in 2024 3 questions were asked, 2023 2 questions, 2022 and 2021 was 3 questions, and you can see from 2020 to 2018 4 questions have been asked. In 27 1 question has been asked. So I can say that after 2017 the weightage has increased for this particular chapter. 4 questions have been asked in this consecutively 3 years, and then you can see 3 questions. So averagely we can say 2 to 4 questions have been asked from this particular chapter every year. Okay, now coming to, yes, starting with the part 1, today's topic, that is position in the periodic table and electronic configuration. So first of all we'll discuss about the position in periodic table. So now you can see now why these elements are called as D and F block elements. Okay, what is the reason? So that is common for all the blocks. Whenever the last electron enters into the particular orbital, the element belongs to that particular block. So in our periodic table we have S block, P block, D block, F block, right? So if the electrons enter to the D orbital, if the last electron enters to the D orbital, then it will be called as belonging to D block element. Similarly, if the last electron enters to the F orbital, we will call it as it is a part of F block. Okay, so you can see the elements of D and F block have their last electron in the D and F orbital respectively. Okay, now D block consists of which groups? Groups number 3 to 12. I'll show you the periodic table also, but you have to remember D block is from group 3 to group 12, and the F block, that is, it consists of 4f and 5f orbitals are progressively filled. So in F block what happens? In F block again we have 4f and 5f, okay. So there the electrons are filled, the last electrons are going to the 4f and 5f orbitals, okay. Now they are placed in the separate panel at the bottom of the periodic table. So this F block is given a separate space in the periodic table. Below the periodic table one box is there, and that is your F block, where we have both 4f and 5f, okay. Now transition metals, so D block, and inner transition elements F block, okay. So D block elements are called as transition metals and F block elements are called as inner transition metals, okay. So now coming to this one, next important here. So as I say, transition elements or transition metals have 4 important series: 3D series, 4D series, 5D series and 6D series. So now remember, this 3D series belongs to the 4th period. I'll write here period. So there are 7 periods in the periodic table. So 4th period 3D series, this is 5th period, okay, and this is 6th period, and this is 7th period, okay. So now in 3D series the element starts from scandium to zinc, and in 4D series it is yttrium to cadmium, then in 5D series it is lanthanum, then hafnium to mercury, and then here in 6D series it is actinium, and then it is Rf to Cn, okay. Now inner transition elements, that is your F block elements, has 2 series that I told you, lanthanides and actinides. So 4F is from cerium to lutetium, this is called as lanthanoids, and 5F series, that is thorium to lawrencium, and here the elements are called as actinoids, okay. So now what you have to remember, in D block there are 4 series: 3D, 4D, 5D and 6D. In F block there are 2 series: 4F and 5F. And you need to know for 3D the elements start only 3D series, you remember the first and the last element, that complete series you have to remember, scandium to zinc, okay, fine. Now I'll tell you this one, you can see this is the general electronic configuration. We'll discuss this in detail, okay. So now you see, in 3D series the electronic configuration is 3D 1 to 10 and 4s 1 to 2, okay. Means it can have, 4s can have either 1 electron or 2 electrons, and 3D 1 to 10 means 3D can have 1 electron or 2 electron or 3 electron or up to 10 electrons. Now here the elements starts from scandium, whose atomic number is 21, and ends at zinc, whose atomic number is 30. Scandium to zinc, okay, 21 to 30. Now coming to next series, that is your 4D series. If you see in 4D series, the electronic configuration is 4D 1 to 10 and 5s 1 to 2, okay. So this is your 4th period, this is from the 5th period, okay. Now here it starts from yttrium to cadmium, so 39 to 48, okay. Now coming to the 5D series, the 5D series is in the 6th period, okay. Now here the electronic configuration is from 5D 1 to 10 to 6s 1 to 2. Here the series starts from 57, that is lanthanum, and ends at mercury, that is 80, atomic number is 80. Now coming to 6D series, this is your 7th period, okay. So here the electronic configuration is 6D 1 to 10 and 7s 1 to 2, okay. Now this is actinium, 89 atomic number, and this series is incomplete, okay. There are still some elements which are not there in this particular series, so the last element we cannot say, it is an incomplete series, clear. So now you can see the periodic table, the position of these elements, that is, these elements, these transition elements are present between the S block and P block, okay. So this part is your S block, this side is S block, and this side is P block. Now you can see this is the first one, that is this is your first period. So if I write the period number also, you can check here. This is first period, second period, third period, fourth period, fifth period, sixth period and seventh period, right. So I can say that we discussed that 3D elements belongs to group 3 to group 12. So that is this one, this part, okay. This much part is your 3D elements, or you can say D block elements. Now here you have, in this particular group or in this particular 3D, there are 4 series. So first one is your 3D series, this is 20 of scandium to zinc is your 3D series, okay, and it belongs to 4th period. Now this one is your 4D series but belongs to 5th period, and then this one is your 6D series, 5D series and belongs to 6th period, and this one is 6D series and belongs to 7th period. And you can see that here these elements are given which is incomplete. Okay, the series here is incomplete, so that is why we mention, we do not like some elements is yet to be discovered, so it is given in that form. Okay, now now coming to this one, what else we can discuss here? Group 3 to group 12, you have to remember 4D, 5D, 6D and 7D series, sorry 4D, 5D and 4, 5, 6, 7 periods, 3D, 4D, 5D and 6D series. Okay. So now coming to F block. So I told you that F block is given a special space in the periodic table below the periodic table. So here you can see this is called lanthanide series. Okay, the first element of lanthanide is cerium, that is atomic number 58. 58 to 71 is the first elements. Okay, first 41, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 elements in the 4F series. Okay, and starting from cerium to lutetium. Now lanthanum is a part here. Okay, lanthanum is here present. After lanthanum, whatever elements are there up to 50 up to 71, they are called as lanthanides. Okay, now similarly here it is actinum present. Okay, actinum number is 89, but the 5F series starts from thorium to lawrencium, that is from 90 atomic number to atomic number 103. Okay, I hope this is clear. This part is 3D, this part is D block present between S and P block. In the D block there are 4 series, that is 3D series, 4D series, 5D series and 6D series. Okay, 3D series belongs to 4th period, 4D series belongs to 5th period, 5D series belongs to 6th period and 6D series belongs to 7th period. Okay, and they belongs to group 3 to group 12. Now coming to your lanthanides and actinides, they have a special position in the periodic table. They are present below the periodic table. Now here we have 2 series, 4F and 5F. 4F starts from cerium to lutetium and 5F starts from thorium to lawrencium. Clear? I hope this periodic table, this things are clear in your mind. Okay. Now coming to next one, that is position in the periodic table. Okay, now we are discussing that only. So now we understood what is D block element, what is F block element. Now what is this word transition element? Why these are called as transition element? So earlier this name was given transition element because they have the properties in between S block and P block. Okay, their properties were in between the properties of S block and P block, but later IUPAC has given a proper definition of transition element. So let us see that now. See, a transition element is defined as one in which it has the incompletely filled d orbitals. Okay, so the d orbitals should be incompletely filled. Now what do you mean by completely filled? If the d orbital has 10 electrons, okay, then it is called as completely filled. If it has less than 10 electrons, then we call it incompletely filled. Okay, so what do you mean by incompletely filled d orbitals? Less than 10 electrons should be there. Okay, in its, so when it should have less than 10 electrons? In 2 conditions: in its ground state or in any one of its oxidation states. Okay, now zinc, cadmium and mercury of group 12 have fully filled D10 configuration in their ground state as well as in their common oxidation state. So there are special case of this zinc, cadmium and mercury. We'll read their electronic configuration, but I'll tell you like now. So zinc electronic configuration is 3D10, okay, 4s2. Now cadmium is 4D10 and 5s2. Now mercury is 5D10 and 6s2. Now what happens is they should have incomplete d orbital either in their ground state, this is their ground state, or in any one of the common oxidation state. Okay, now if I see the common oxidation of zinc, zinc has a common oxidation state of +2. Now if I see Zn2+, that is the common oxidation state. Now what do you mean by Zn2+? Zn2+ means 2 electrons have been removed from zinc. Okay, 2 electrons have been removed from the zinc. Now 2 electrons will be removed from the outer orbital, okay, from the outer shell. So 3D will be inner shell, 4s will be outer shell. So 2 electrons must be removed from 4s. So what will be the configuration of zinc? It is 3D10 and 4s0. So I can just write it as 3D10, right? So now you see that for zinc, if you see for zinc, it has 3d10, that is fully filled d orbital configuration in its ground state, okay, in its ground state and also in its oxidation state, common oxidation state, okay, common oxidation state. Now if you see in both these cases, the d orbital is fully filled, right? In both the cases the d orbital is fully filled. Now when the d orbital is fully filled in both the cases, then we cannot call it as a transition element. So what is the criteria of transition element? The d orbital should be incompletely filled. Now what I mean by incompletely filled, that it should have it should not have 10 d electrons. There should not be 10 electrons in the d orbital. It should be less than 10. Okay, so it should be incompletely filled either in its ground state or in the common oxidation state. If any one of these is happening, then we can call them as a transition element. Now for example, if you see zinc, zinc has fully filled d orbital, both in its ground state and also in its common oxidation state. The common oxidation of zinc is +2. So in both these states it has fully filled d orbital, so we cannot call them as a transition element. So what is the name given for this them? Therefore they are called as pseudo transition element. Okay, these are called as pseudo transition elements. Okay, questions have been asked from here, so very important. Okay, now let us move to the one question from here. Now see, why is copper a transition element whereas zinc is not, while both have D10 configuration? This question will solve after seeing the electronic configuration, then we'll come back to this question. Okay. So now let us see the electronic configuration here. So this electronic configuration is for 3D series, okay, and you have to remember, without remembering the electronic configuration you cannot do this question. So for 3D series you have to remember the electronic configuration at any cost if you want to master this topic. Okay, so I want everyone to comment down that whether this 3D series you are going to remember or not, and those who have already remembered, they need to type or they need to comment that they have already remembered, and those students who haven't, they also need to comment that they haven't and they will do it definitely. Okay, I want all my students to promise that they will remember this 3D series, because otherwise you will not able to touch even a single question from this chapter. Okay, it is very difficult to do even the easiest questions you cannot solve if you are not confident with the electronic configuration. So only 10 elements you have to remember: scandium, titanium, that is 3D series. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. I want these 10 electrons, this 10 elements electronic configuration should be remembered by all of you. Okay, now so here the atomic number is given. Okay, so this is atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, I'll tell you a trick how to remember. So you have to first remember this atomic number, and the 21 is scandium, 22 is vanadium, 22 is titanium, 23 is vanadium, 24 is chromium, 25 is manganese, 26 is iron, 27 cobalt, 28 nickel, 29 copper, 30 is zinc. First you have to remember this. Next we know that 3D series has the electronic configuration of 3D4s. Okay, so what you have to do is, suppose the atomic number is 21, that is scandium, then 3D will be 1, okay, and 4s is 2. Okay, 4s is 2. Now coming to titanium, if I have titanium, that is 22, then the electronic configuration is 3D2. You see the last number here is 2, so here it will be 2 and 4s2. Right, now if you see now vanadium, okay, if you see vanadium, it is 23, so what will be the electronic configuration? The electronic configuration here will be 3D3 and 4s2. Now coming to chromium, we will discuss later. Okay, chromium I am leaving now. Now coming to manganese, here it is 25, so 25 means 3D5, then 4s2. Then coming to iron, it is 3D, I will write 4s, 4s will always get 2, and iron will get 3D6 because its atomic number is 26. Now coming to cobalt, cobalt will be what? Cobalt is 27, so I will write 3D7 and 4s2. Nickel will be 3D8 and 4s2. Now copper also will discuss later. Zinc I can say that 30, so 30 means I will put 3D10 and 4s2. Okay, so these electronic configurations you have to remember. Okay, otherwise we cannot solve the very easy questions, we cannot solve. Okay, Now coming to, I left two elements, right? Chromium and manganese. Let us discuss that now. See, chromium electronic configuration, the atomic number of chromium is 24. So if I follow the rule that I told you, the 4 is there, 4s2 will be there and 3d4 will be there. Now what happens, d orbital, if you know from structure of atom chapter, d orbital, d subshell has 5 orbitals, right? So 3d4 means 1, 2, 3 and 4. Now what happens, total it can hold 10 electrons, now it has 4 electrons. So now if in any way it can hold 5 electrons, if I make 3d5, then what is the special? It is exactly half filled configuration, right? It will become exactly half filled configuration. Now if it is an exactly half filled configuration, then what will happen, that electronic configuration becomes more stable. So that is why what happens, one electron is given here and we get 3d5 and 4s1. 3d5 and 4s1 for chromium. Similarly, if you see for copper, copper is 29 atomic number. So if I write, I will get 3d9 and 4s2, the rule that we follow. Now if I get one more electron here, then it will become fully filled electronic configuration, okay? So that will be more stable. So what I get, 3d10 and 4s1. Okay, so this is two exceptional electronic configurations that you have to remember for chromium and copper. So now again you have to comment down chromium and copper electronic configuration. Everyone must type chromium and copper electronic configuration and let me know that you have remembered these two exceptions. Okay, now we can come back to the question that we have left here. Now, why is copper a transition element whereas zinc is not, while both have D10 configuration? Now see, what is the definition of transition element? Transition element should have unfilled, or I should write, we use the word incompletely filled d orbital, right? Should have incompletely filled d orbitals, right? Where these incompletely filled d orbitals should be there, either in the ground state, okay, either in the ground state or in the excite, or in the, I can write, any common oxidation state, or in any common oxidation state, or any common oxidation state, right? Now we have been given with two things, that is copper and zinc. So if you see, copper electronic configuration is 3d10, just now I have discussed 3d10 4s1. This is in ground state, okay? So copper has two important oxidation state, that is copper plus 1 and copper plus 2. So if I see copper plus 1, then its one electron will go from here, its configuration will be 3d10. Now if I get copper 2 plus, one electron will go from here and one electron will go from here, so I will get 3d9, right? Now you see for zinc, zinc, what is the electronic configuration in the ground state? It is 3d10 and 4s2. Now zinc has only one common oxidation state, that is plus 2, and I will get 3d10, right? Now you see that for copper, okay, for copper, in this one of the common oxidation state, that is Cu2 plus, this is incompletely filled. This is incompletely filled. But for zinc, in the ground state and in the common state, it is d orbital is fully filled, right? So I can say that copper has D10 configuration, copper has D10 configuration in the ground state, but not in the common oxidation state, right? So because it doesn't have a completely filled d orbital in the common oxidation state, we can say that it has incompletely filled d orbitals. Now because it has incompletely filled d orbitals, copper is a transition element. Copper can be a transition element, but zinc cannot. I hope this is clear. Copper has fully filled d orbital in a ground state, but in the common oxidation state, it has incompletely filled d orbitals, right? So by definition, we can say that this is a element where there is incompletely filled d orbitals in the common oxidation state, so we can consider it as a transition element. But zinc has fully filled d orbital both in its ground state and in its common oxidation state, so that we cannot consider it as a transition element, okay? Fine. So now this is your 4D series electronic configuration. You need not remember. In 5D also, that is not required. For 3D you have to remember, that is from scandium to zinc. Okay, 3D electronic configuration must remember, must, otherwise you cannot do the easiest of the questions also. Okay, fine. Now let us do some very interesting questions, very easy questions. Which element is not a D block element? So if you know, lead is your element from the P block, right? So the correct answer for this question will be option number B. Very simple one. Even if you do not know this, you might be knowing that lead belongs to this P block element, right? So that is why we can choose that answer. Next question, how many D electrons are present in Cr2+? See how to do these type of questions. First, step 1. Step 1 is write the electronic configuration of the chromium in ground state. So it is 3d5 and 4s1. Okay. Now if I want to write step 2, step 2 is you have to write the electronic configuration of Cr2+. Cr2+ means you have to remove 2 electrons, okay, and the 2 electrons, the first electron will be removed from 4s and the next electron will be removed from 3d5. So first I'll elect 1 electron and then I'll remove 1 electron from here, so I'll be left with 3d4. Okay, so if I do 3d4 is like this, 1, 2, 3 and 4. So the total number of unpaired electrons are, or how many D electrons are present? 4 D electrons are present in Cr2+, right? Okay, next, the last electron in the D block goes to, so see, 3D if I tell and 4s, right? So first the 4s orbital is filled, this is first filled, okay, this is first filled, and then this is filled after that, I can say last filled. Okay, so now it goes to D orbital, definitely we know that. Now the highest value of n is 4, the highest value of n is in this case 4, and so this is n minus 1 D. So where does the D orbital enter? The D orbital and the D electrons enter the n minus 1 D orbital, or the electrons enter the n minus 1 D orbital. Okay, so the correct answer for this question will be option number A, that is n minus 1 D. Okay, you can see this is for 3D series. If you see for 4D series, what is the electronic configuration? 4D 1 to 10, 5s 1 to 2. For 5D series, if you see, this is 5D 1 to 10 and 6s 1 to 2, right? So this is your n value and this is your n minus 1 value. So the D electrons enter to the D, that is n minus 1 D cell. Okay, the correct answer for this question is option number A. Okay, now let us do some PYQs. Okay, so this question was asked in 2023. In which one of the following pairs both the elements does not have n-1 D10 and ns2 configuration in its elementary state? So both the elements should not have n-1 D and ns configuration. Okay, so here if you see zinc electronic, so let me write down here, zinc electronic configuration is 3d10 and 4s2. Then cadmium electronic configuration is 4d10 and 5s2, right? So if you see zinc and cadmium both have 3d like n-1 D10 and ns2 configuration, so this cannot be answer. Okay, now coming to cadmium and mercury. If I tell mercury, okay, mercury is 5d10 and 6s2, right? So here also the electronic configuration is n-1 D10 and ns2 configuration, so this also cannot be the answer. Now mercury and Cn, here also if you see, so this is actually mercury and cadmium only, option was there CD. So cadmium mercury, mercury cadmium both will have same one, so we can eliminate. One second. So now let us solve some PYQs and understand what is our level of preparation. Okay, so in which one of the following pairs both the elements does not have n-1 D and ns2 configuration in its elementary state? So both the elements should not have n-1 D10 and ns2 configuration. Okay, now if you see zinc, okay, so zinc electronic configuration is 3d10 and 4s2, and cadmium electronic configuration is 4d10 and 5s2. Right, now if you see 3d10, 4d10, 4s2, 5s2, so both of them are having n-1 D10 and ns2 configuration, so that is why this option is wrong. right? The question is asking both the elements should not have. Now if you see Cd and Hg, right? So mercury I will add here. Mercury is 5d10 and 6s2. So here also you see cadmium is having n-1 d10 ns2. This is also having n-1 d10 and ns2 configuration. So this also option I can eliminate. Then if I see Cn, Cn has 6d10 and 7s2 configuration. So here also you see this is 5d10, this is 6d10. So both are again having n-1 d10 and ns2 configuration. So this cannot be the answer. Now if I see copper, okay, so copper is 3d10 but 4s1. So here one element is not having, the other element is having, right? Both the elements here are not having n-1 d10 and ns2 configuration, right? So the correct answer for this question will be option number D. Okay, very simple question. So this question you can easily solve if you know the electronic configurations, right? That is why I told you it is very important to remember the electronic configurations. Okay, next, which one of the following is correct for all the elements from scandium to copper? Okay, the lowest oxidation state shown by them is +2. Okay, we'll see this. 4s orbitals is completely filled in the ground state. We have to tell which is the correct statement. Okay, 3d orbitals is not completely filled in the ground state. The ions in the +2 oxidation states are paramagnetic. Okay. Now, if you see the lowest oxidation state shown by them is +2. So when we study oxidation state, we can see that copper is an element from here, that is scandium to copper, but it has a lowest oxidation state of +1, right? So that is why this statement is incorrect, because there is one element which shows even +1 oxidation state. Now coming to this, 4s orbital is completely filled in the ground state. Just now we saw for chromium and copper, right? The 4s orbitals are filled 4s1 and 4s1. So that is why this statement is also incorrect. Now 3d orbital is not completely filled in the ground state. So 3d orbital is not completely filled in the ground state. Now if you see for many elements, like if you see like scandium, titanium, vanadium, right? So if you see 3d1, here it is 3d2 and here it is 3d3, right? Now if we see the 3d orbital is not completely filled in the ground state, this can be a correct statement, right? So that it is not mandatory that every element has 3d, every element in their ground state must have 3d completely filled. There are almost every element except copper and zinc whose 3d orbitals are incompletely filled in the ground state. Now coming to this one, the ions in the +2 oxidation states are paramagnetic. So if you see paramagnetic means what? They should have unpaired electrons. Okay, they should have unpaired electrons, then it is called paramagnetic. Now if I see zinc in the +2 oxidation state configuration is 3d10, there is no unpaired electron, so it is diamagnetic. So this statement is also wrong. The correct answer for this question will be option number C. Okay, very clear? Okay, next, identify the set of paramagnetic ions in the following. Okay, if you identify the set of paramagnetic ion, you have to write the electronic configuration and you have to see which option is having, like all the elements are having some unpaired electrons. Okay, so for that what I can do is, if I see Zn, okay, Zn2 plus, just I discussed, the electronic configuration is 3d10 and it is diamagnetic because it has fully filled, all the 10d orbitals are fully filled. So I can eliminate this option. Now if I see scandium, what is scandium electronic configuration? 21, right? 4s2 3d1. Now if I see scandium 3 plus, then all its electron will go, right? 4s2 will also go, 3d will go, so it is only argon. Now argon has a fully filled electronic configuration, so that is also diamagnetic. So I can eliminate this option also. You need not check everything, you can just check one element. Titanium, scandium titanium. Titanium electronic configuration is 3d2 and 4s2, right? So Ti plus 4 will have, again these two will go, have the electronic configuration only for argon, which is again diamagnetic. So that is why we can eliminate this also. Correct answer for this question will be option number B. You can write the electronic configuration and then check how many number of unpaired electrons are there in each of these cases. Okay, that is again you have to comment down in titanium 3 plus, copper 2 plus and manganese 3 plus, how many unpaired electrons are there. Okay. Now coming to question number 4, the elements in which the electrons are progressively filled in the 4f orbital. So if 4f orbitals are filled, we call them as lanthanides. 5f orbitals are filled, we call it as actinoids. Okay, fine. Okay, so this is an homework question for you, the electronic configuration of Fe3 plus S. Okay, so I want everyone to study, remember the electronic configuration and do this question and comment down the answer. Okay, so yes, that was the part 1 of DNF block. So a very short topic this one, but yes, it is the foundation basics of DNF block you must understand. Okay, so if you are finding these videos helpful, if you are liking this series, then please subscribe the channel and please do not forget to join our WhatsApp channel. And remember, next class we are going to discuss the very most important topic, that is the physical trends and physical properties of this DNF block. So there are almost 14 properties that we will be discussing. So yes, definitely stay tuned for the next class. Thank you for watching once again and subscribe the channel for more such videos.